Hello and welcome to Medical Dialogues. I'm Anshika Mishra. Here's what I bring to you from the world of medicine. Youth-onset diabetes linked to increased Alzheimer's risk study. According to a new study by researchers in the Life Course Epidemiology of Adiposity and Diabetes Center at the University of Colorado Anschutz Medical Campus, young people with diabetes may have a significantly higher risk of developing Alzheimer's disease later in life. In the study published in journal Endocrines, scientists showed the presence of specific blood biomarkers indicating early signs of neurodegeneration and Alzheimer's disease in young people with youth-onset diabetes. Youth-onset diabetes, particularly type 2 diabetes, is associated with various metabolic abnormalities and vascular complications that can contribute to the development of Alzheimer's pathology. Additionally, insulin resistance and chronic hyperglycemia, common features of diabetes, may impair brain function and promote the accumulation of amyloid plaques and tau tangles, characteristic hallmarks of Alzheimer's disease. Moreover, diabetes-related vascular damage can disrupt blood flow to the brain, exacerbating cognitive decline and increasing the risk of brain-related disease. The study examined approximately 80 individuals utilizing blood biomarkers and PET scan to detect signs of neurodegenerative disease in young adults living with diabetes. Study finds cell that may be key to treating obesity. In a study published in journal Cell Metabolism, researchers identified a population of cell in human or mental adipose tissue that hinders the formation of new fat cell, process known as adipogenesis. Understanding how fat tissue forms and function is crucial for addressing obesity and related metabolic diseases. However, adipose tissue or body fat behaves differently based on its location in body. Adipose cells, commonly known as fat cells, exhibit distinct behavior depending on the location in the body. Subcutaneous fat found just beneath the skin serves as an energy reserve and provides insulation against temperature changes. This type of fat tends to be more metabolically active and can readily release fatty acids for energy when needed. In contrast, visceral fat, which surrounds the internal organs such as the liver, pancreas, and intestine, is more hormonally active and secretes inflammatory substances that can contribute to insulin resistance, metabolic syndrome, and cardiovascular disease. Visceral fat is less responsive to signals that regulate fat breakdown and tend to accumulate more easily in individuals with obesity or metabolic disorders.
Are you also aspiring to excel in medical journalism and delve into the intricacies of health and medical reporting? Explore our comprehensive course on medical and health journalism available at the Medical Dialogues Academy. Learn from industry experts who possesses in-depth knowledge and experience in this field. For further details, scan the QR code provided or access the link in the description box below.
Can changing eating time aid healthy aging? Study sheds light. A study published in journal Science suggested that adjusting eating times to manipulate the circadian rhythm, which governs our sleep-wake cycles, may protect muscle function among older individuals. Our bodies operate on an internal clock called the circadian rhythm, which orchestrates our sleep-wake cycles. This rhythm is finely tuned by exposure to light and darkness, and disruptions to it, such as those experienced by shift workers, can have significant health ramifications. As we age, changes in our sleep-wake cycle often accompany the loss of muscle mass. Research suggests a close interplay between these two phenomena. While most individuals experience a shift towards earlier sleep hours with age, some, particularly those with neurodegenerative conditions, may encounter severe irregularities in their sleep patterns. Clock genes play a crucial role in regulating circadian rhythm. As animals age, studies have observed a decline in expression of these genes, potentially leading to disruption in their circadian rhythms. While human research in this area is still limited, similar mechanism could be at play. In their study, researchers utilized a mouse model with a BMAL1 knockout, preventing the expression of this critical clock gene which regulates circadian rhythm, particularly in the brain. However, they were able to reintroduce BMAL1 in various tissues, including skeletal muscle. ICMR issues new dietary guidelines, warns against regular use of protein supplements. The Indian Council of Medical Research has released new dietary guidelines advising the public on healthy and nutrition practices, including recommendations on protein intake. A key point from the guideline is the recommendation against the frequent use of protein powders and supplements for muscle building and dietary purposes. According to the ICMR, while protein is an essential nutrient for muscle and overall body health, the regular consumption of protein supplements can be unnecessary and potentially harmful. Protein powders powders, which are derived from sources like dairy, eggs, whey, and plants such as soybeans, peas, and rice, often contain added sugar, artificial sweeteners, and other additives that may not be advisable for regular consumption. The guidelines emphasize that obtaining high-quality protein and essential amino acids through a balanced diet is more beneficial than supplementing within protein powders. This approach not only prevents the risk associated with high protein intake, such as bone mineral loss and kidney damage, but also ensures that the protein consumed is effectively utilized for bodily functions. Thank you for watching. Stay tuned to Medical Dialogues for more updates.
Never miss a medical update from Medical Dialogues. Like, subscribe, and press the bell icon.